Najwa. I'm the project manager for this project. Next, I would like to introduce my team members. Nordia Dayani as the system analyst, Nur Atika Najihah as the programmer, and lastly Nur Amalin as the tester. We are from section 01C and our project is about Easybook. Easybook is an online ticket booking platform that let you search, check schedule, compare the price, pick your seat, book your ticket, and pay online just in one place. Booking bus, ferry, or train ticket become more easier just using Easybooks.
Hi, my name is Dia. I am system analyst for this project. So I will give a short explanation about Easybook. First, I will explain the objective of the Easybook portal. So, Easybook is an online platform that helps users plan and purchase travel tickets easily through the internet. So with this platform, users do not need to queue at ticket counters, which helps save time and makes the booking process more convenient. Besides that, Easybook offers its service across multiple countries in Southeast Asia, making it suitable for both local and international travelers. Lastly, Easybook also helps users save travel costs by offering competitive prices, discount, and special promotions. So overall, the main objective of the Easybook is to provide a fast, convenient, and cost-effective way for users to book their travel tickets. Next, I will explain why we choose the incremental process model for the Easybook project. It is the most suitable model for Easybook because it is flexible and supports continuous improvement. In this model, the system is developed in small functional parts, also known as increments, and each part is improved step by step with continuous user feedback. This approach is very suitable for Easybook because it involves complex and evolving services such as bus, train, and ferry ticket booking, dynamic pricing and discounts, and online payment integration. These features are often require improvements and through testing as the system evolves. Another important reason is that it helps to reduce overall development costs. This is because Easybook is a system that requires frequent updates such as adding new bus routes, adjusting promotions, or changing holiday schedules. Since each module is developed and tested separately, errors can be detected early, which helps reduce rework and additional costs in later stages. In addition, the project budget can be distributed across different development stages, making cost control and financial planning more efficient. Next is about detailed process activity for the incremental process model. First is the specification phase. In this phase, I identify and define the required functionalities of the Easybook system, also gather user requirements for each module, ensuring that both functional and non-functional requirements are clearly defined. This helps the development team to understand exactly what needs to be delivered in each development cycle. Instead of gathering all requirements at once, we prioritize them based on importance. For example, in the first increment, we focus only on user registration and login. Other features such as ticket booking, payment integration, and seat selection are added in later increments. Next is the development phase. In this phase, the Easybook system is designed and developed based on the specific requirements. Once the requirements are clear, we begin coding each increment step by step. For example, we start by designing the user interface and developing the feature that allows users to search for bus routes. Then, we implement functions to display schedules and enable ticket booking. After the development, the system goes through the validation phase. Each Easybook component is tested individually before integrating it into the full system. Selected users are also involved in testing to provide feedback. This really helps me to identify and fix issues early before moving on to the next increment. Lastly is the evolution phase. Even after features are implemented, user needs may change, such as requesting additional payment options, updated bus schedule, or improved search filters. The incremental model allows these changes to be made easily without disrupting the entire system. This ensures that Easybook continues to evolve according to user needs and remains relevant and effective for customers.
Next, I will explain the importance of early user involvement in release testing. As a programmer, early user involvement is very helpful because it allows us to detect functionality and usability problems earlier. Normally, programmers focus more on technical correctness, such as whether the search returns results or whether the booking process is successful. From our perspective, if the system runs without errors, we assume it works fine. However, actual users test the system differently. Users interact with the system based on real usage, not technical logic. For example, users may point out issues such as a booking process that is too complicated or unclear or difficult search function. These are problems that the programmers may not easily notice during development. This type of user feedback allows programmers to fix logic problems in the code, improve interface behavior, correct bugs early in development, and fixing problems at this early stage is cheaper and simpler compared to making changes after the system is fully deployed and already in operation. Another important benefit of early user involvement is that it helps ensure that the features implemented truly meet user needs. User feedback during release testing helps programmers confirm whether the system functionality is realistic in the real world, not just correct from a technical point of view. For example, Easybook users may suggest clearer payment summaries or better error message when payment fails. With this feedback, programmers can improve system logic, validation rules, user feedback message in the code. This helps create a more user-friendly system with fewer major changes needed in later development iteration. However, early user involvement also comes with challenges, especially during the validation and verification stage. At this stage, most system components are already developed, and programmers are focusing on system stability. If users request major changes such as changes in the payment flow and refund process, programmers may need to refactor existing code, which increases rework. This rework can affect system stability, introduce new bugs, and slow down development. If core modules are affected, the project timeline may be extended and system delivery can be delayed. In conclusion, early user release testing provides valuable insight that help programmers improve the functionality and usability of the system. However, user feedback must be well managed to avoid excessive rework. As a programmer, it is important to balance user participation so the system remains both user-friendly and technically stable.
For our project, we choose the MVC pattern because it provides a clear separation of concept. In Easybook, the model handles booking and payment data. The view manages the user interface and the controller controls the system flow. This makes the system more organized and easier to maintain. Secondly, the MVC pattern improves the system flexibility and reusability. The core business logic can be reused across the different platforms such as the website and mobile application. This allows Easybook to add new features or update the interface without affecting the entire system.
In the development of complex systems such as the Easybook online ticketing platform, effectively communication and handover between developers and testers are critical to ensuring the quality, the functionality, and durability of the system. As a tester, my primary responsibility is to verify that each module of the system operates according to functional and non-functional requirements, that it integrates correctly with other modules, and it's delivered a seamless experience to users. One major handover problem that I may face in this role is incomplete or ambiguous documentation provided by developers during module delivery. This problem happens when developers deliver a new module without supplying suspicious detail about its integrate functionality, integration point, data flow, or no limitation. In the context of Easybook, where the system is being developed using the incremental model, software is built and delivered in a small increment that must be truly tested before being integrated with the larger system. If documentation is incomplete or unclear, it's become difficult to understand how a module is supposed to function, which directly affect my ability to create accurate and comprehensive test cases. For example, if a new booking module does not clearly explain how the system handles seat selection across multiple operators, I may overlook concurrency issue or double booking errors. Similarly, with missing detail about API response or handling in the payment processing module, it's result in undetected defect that affect transaction reliability and user satisfaction.
Okay, for this slide, I will explain one handover problem in the Easybook project based on my role as a programmer. In the Easybook project, we used the incremental development model, where the system was developed in small increment. As a programmer, my main responsibility was to translate system designs into executable code for each increment, such as booking, payment, seat selection, and discount module. However, because of tight deadlines and frequent requirement changes, not every increment could be fully reflected or properly documented. This creates a handover problem after the system is delivered to the client. The main problem is that the maintenance or evolution team may struggle to understand the system because the code has gone through many incremental changes, but the documentation is incomplete. As shown in the diagram, this problem affects several important modules such as booking, payment, seat selection, and discount processing. Each module was updated in a short cycle. Over time, some changes may exist in the code but are not clearly documented. For example, in the payment module, new payment methods like FPX or e-wallet may be added quickly to meet user demand. However, if these changes are not properly documented, the maintenance team may not fully understand how the payment flow works. The same situation can happen in the booking module, where new seat selection rules or discount logic are added incrementally without clear explanation. This leads to several consequences. First, the maintenance team struggles to understand the system, which makes maintenance and updates slower. Second, during the evolution phase, which is usually the most expensive stage, maintenance costs may increase instead of decreasing. Finally, error may occur in critical modules such as failed payment transaction, incorrect seat allocation, and misapplied discount. This error directly affects system reliability and customer satisfaction. When these problems happen, the overall project quality is affected. System reliability decreases, customer satisfaction drops, and the cost of maintaining the system becomes higher in the long run. This shows that poor handover does not only affect the maintenance team but the entire project life cycle. In conclusion, a major handover problem in the Easybook project is the difficulty faced by the maintenance team in understanding and managing the system due to the frequent incremental changes and incomplete documentation. As a programmer, this highlights the importance of proper documentation and clear code structure to ensure a smooth handover and successful system evolution.
The effect of this problem on my role as a tester is substantial. Firstly, it slowed down the testing process, as I would need to spend extra time to clarifying ambiguities with developers, reverse engineering, module behavior, or creating assumption to proceed with testing. This increases the overload and can create delays in completing test cycle. Secondly, it will increase the risk of defect being missed, particularly for critical functions such as seat reservation, booking confirmation, and payment processing. This missed defect could lead to operational failures, negative user experience, and a loss of trust in Easybook platform. Thirdly, it will affect the overall efficiency of the iterative development process because undetected defect in one increment can propagate into later increment, creating additional challenge for both testing and integration. The consequence of incomplete documentation extend beyond my role as a tester, since the incremental model relies on continuous testing, validation, and feedback from each module. Any gaps in documentation can affect the project timeline, compromise the accuracy of the verification process, and impact the quality of the final system. For instance, if the tester cannot fully understand module functionality due to missing documentation, important tests can maybe skip, resulting in module being released with hidden defect. In Easybook, such defect could manifest as failed booking, double charge, or system crash during peak travel period, all of which undermine the project success. To solve this problem, Proactive strategy must be implemented. Tester should be involved early in the design and development phases, participating in design review and developer discussion to clarify module functionality and expected behavior. Developers should provide comprehensive handover documentation, including functional specification, API detail, integration guideline, and no limitation. Additionally, maintaining a shared documentation repository ensure that all team members, including testers, have access to up-to-date and accurate information. This measure allows testers to perform through validation and verification, identify defects early, and support the continuous improvement cycle of the iterative model. In conclusion, incomplete or ambiguous handover documentation is a significant problem that I directly affect my role as a tester in Easybook platform. It can slow down testing, increase the risk of undetected defect, and compromise the overall quality and reliability of the system. Within the incremental model, where each increment relies on through testing before integration, this problem can also affect timelines and final system performance. Addressing this challenge through early involving in design, clear documentation standard, and effective communication ensure that I can carry out my role effectively, contributing to the delivery of a secure, reliability, and user-friendly Easybook platform.
As a system analyst, involving users in early release testing is important to ensure that the Easybook system meets user requirements and expectations. When users test the system early, they can check whether the key features such as searching routes, selecting seats, and booking tickets are clear and easy to use. This helps confirm that the system workflow is practical and understandable. By doing this early, we can reduce misunderstandings in user requirements and avoid costly changes at later stages. Early user testing also allows users to provide feedback based on real usage. As a system analyst, once I receive this feedback, I analyze and document the issues such as confusing booking steps, missing information, or unclear search results. I then prioritize these issues based on their impact and urgency and communicate them clearly to the development team as system change requests or requirement updates. This ensures that the right problems are addressed first and according to user needs. In addition, users test the system on different devices, browsers, and the internet speeds. This allows me to identify performance and usability issues such as slow loading pages or errors during booking before the system is fully released. In conclusion, involving users early in release testing allows me to identify, analyze, and manage user feedback effectively, reduce system risk, and ensure that the Easybook delivers a fast, reliable, and user-friendly booking experience.
The first benefit of involving users in early release testing stage is early identifications of usability and functional issues. When the real user tests the system, they may find problems such as unclear workflow, confusing navigation, or system error that are not detected during internal testing. Identifying these issues early allows the team to make improvement before the system becomes more complex, which reduces reward at later stage. Next, the second benefit is increased user acceptance and confidence. When users are involved in system development process, they feel that their opinions are valued and considered. Early exposure to the Easybook system help to reduce resistance because users are already familiar with how the Easybook system works. This involvement helps to build trust and encourage users to adopt it more easily when it is officially released. However, there are one disadvantage of user involvement during validation and verification stage, which is difficulty in managing diverse user opinions. Different users may provide different type of feedback based on their own needs and experience. Some users may also request features that are outside of the Easybook system. As a result, the project team need to carefully evaluate which feedback are relevant to consider. If too many requests are considered, this may lead to the scope creep, increased development effort, and the project schedule is delayed